Okay, I'm back. Too many Snapples leads to, a sudden need to go to the bathroom. Anyway, so the fourth term of a sequence is 360. The eighth term is 4 and 4 ninths. Find the 10th term. Okay, so we can relate these two terms, the fourth term and the eighth term, by the following little relationship here. So the eighth term equals the fourth term times our common ratio, r to the n. In this case, there are 4 terms in between, well, from a to the fourth to a to the eighth is 4 terms, so actually I'm just going to make this into a 4 right here. So that's a 4. All right, so we just need to plug in the numbers and so we can get our common ratio. So we got the eighth term, which is 4 and 4 ninths. And we have the fourth term, which is 360. And we have r to the fourth. So we're just going to divide and then take the fourth root, and we will have the number that we're looking for. So we're going to do 4 and 4 ninths, which by the way is 4.4 repeating. And after we do some nice fun work here, we get that the common ratio for r is exactly 1/3. Just a little calculator work. So we know now that the common ratio is 1/3. So for yep. Find the 10th term. All right. So now I go back to the generic formula that we have. We know we have a sub n equals a sub 1 r to the n minus 1. So then we just plug in the numbers. So we know that actually we need to back up here a little bit, don't we? So we need to back up and get our first terms here. So in order to get the previous term from 360, because 360 is the fourth term, so we need the third, second, and first term. So all we need to do is just keep multiplying by 3. So 360 times 3 will be that will be the third term, and that is 1080. So we have a3 equals 1080. a2 multiplied by 3 again times 3, and we got 3240. And a1 multiplied by 3 again, and we have 9720. Okay, so now we can use our formula here. So we got 9720 times common ratio to the, and so we're going to find the 10th term. So we're going to do 10 minus 1, or 9. So 1/3 to the 9th power. So this is 1 divided by 3 to the 9th equals some tiny number times 9720. 9720 equals 0.4938. 0.4938. So that's using the formula. Now, of course, we could have just, once we found out that the common ratio was 1/3, we could have just taken 4 and 4 ninths, which was the eighth term, and just multiplied by 1/3, and then 1/3 one more time, and that would also get us to the 10th term. I wanted to make sure we were able to do the formula method as well. So again, if we knew the eighth term, keep losing it, eighth term was 4 and 4 ninths, we would just have to multiply by the common ratio 2 more times to get to the 10th term. Or similarly, we could say 4 and 4 ninths times 1/3 to the second power would also get us there. So 2 methods to get to that same location. Okay, so yeah, good. So we are going to have 2 different summations here. One for a finite geometric series, and then we're going to look later at an infinite geometric series. And so I want to take a look at this strange looking formula stuff right here. So S is going to stand for the sum of the nth term here, because we're going to do only the sum of a certain number of terms. And this sigma right here stands for, or is the Greek letter S, which stands again for sum. And we're going to take the sum starting when I equals 1, and we're going to go to n, whatever n happens to be. In this case, for our first example, it's going to be 10. Of the first term times the common ratio to the I minus 1. So this is the way we usually set these up. And here's the formula. The first term times 1 minus the common ratio to the nth power over 1 minus the common ratio. So again, this sigma notation here, sigma, just means sum. Just add stuff up. So take the first term plus the second term plus the third term and so on. But the important thing here is here's the formula, and the notation is just, it looks a little confusing, but it's not really anything terribly difficult. And in fact, I'm actually going to backtrack a little bit in just a moment and go back and take a look at the summation for arithmetic sequences. So it says find the sum of this thing right here. So easy enough. All we need to do is just plug the numbers into the formula. So we're going to get S sub n, that's the sum, equals the first term, which is 6, times 1 minus common ratio, which is 0.2, to the 10th power, right? Because that's n is 10, right? N is up there. So that's 10 over 1 minus the common ratio. Okay, so we just do the stuff. So 0.2 to the 10th power equals, and we subtract that from 1. And we get a whole lot of 9s, by the way. And then we divide that by 0.8, because 1 minus 0.2 is 0.8, so 0.8 equals, and we get 1.2499999. So equals 6 times 1.2499999. So I'm actually going to go that's really 1.25. So 6 times 1 1/4. Somebody's texting me a lot. Okay. It's Miss Pender. So gotta multiply 1.25 times 6 equals 7.5. So 7.5 or 7.5 is our answer. So that's pretty cool. So we know that we, okay, I'm gonna turn the phone off. Okay, good. Sorry about that. So, so we know when we're doing the sum of the first 10 terms of this, we get that. Okay. Actually, yeah, let's keep going. So I'm gonna jump to arithmetic sequence. So I'm just gonna jump backwards a little bit because while we're talking about this notation, I want to keep talking about the notation. So we've already seen this formula. The sum of an arithmetic sequence is this formula right here, n over 2 times the first term plus the last term. And so this little bit of notation here is the only thing that's new. I just want to make sure that you see it. So again, sigma means sum of the first n terms, so 1 to n. So term number 1 plus term number 2 plus term number 3, ... until we get to the nth term. So that's our formula in that format. So find the sum of this situation right here. So I want you to see this format here. So find the sum. Well, that's easy enough. We're just going to use our little formula right here. So we know that our first term, I equals 1, that's 1, is going to be 1. And our n in this case is 60. So we got 60 over 2 times 1 plus 60. Because our 60th term in this case is just, well, 60, right? Because it's 1 plus 2 plus 3 and so on. And something I need to make you aware of. So when it says 1 to 60, there are, so if we said we're going to go from, oh yeah, this is good, I'm good. So we got 30 times 61. So that's going to be 61 times 30 equals 1830. So there you go, just using our summation notation to set up the problem, just so you're familiar with this. So, and I'll give you a couple problems with that to do also. All right, we're nearing the end here. I already did this. Let's go up to this one right here. So find the sum, same kind of situation right here, but notice that this isn't just I, it's 3I. But we remember that this, we can just factor out that 3 and kick it onto the outside there, is going to be the same as this. So I equals 1 to 12 of I. And so then we're just going to be able to do 3 times n over 2, so in this case 12 over 2, times the first term, which is 1, and the last term, which is 12, and so 12 over 2 is 6, times 13 is 78, times 3 is 234. Yeah, 234. Again, just plug in the numbers into the formula, right? N over 2, A1 plus A sub n. And then we multiply it by that 3 that we factored out right there. Okay. So, finding the sum of this guy right here. All right. So when we look up here, when we go from 1 to 12, we know that there are 12 terms, because 1, 2, 3, 4, and so on. It makes 12, right? We get to the 12th term. However, if we were to try to figure out how many terms there are here, it's pretty easy. Again, we already know the answer is 12, but we might be tempted to just subtract. 12 minus 1 is 11. That's not the number of terms here, right? The number of terms here is actually 12. So in order to figure out the number of terms, the way to do that is we take the top number, 12, minus the bottom number, 1. So 12 minus 1 is 11, and then we add 1. That little concept is going to come in handy right here, because we don't always start at the very beginning with the first term. Sometimes we start somewhere in the middle. Like here, for this example, we're starting at the 7th term. So again, it's tempting here to do 11 minus 7. Well, that's 4. Nope, there are actually 5 terms here that we need to worry about. So that's something that we need to consider here. So, yeah, so we're going to factor out the 6. We're going to kick the 6 out onto the other side there. So we have 6 times the sum of I equals 7 to 11 of I. And so we know that's going to be 6 times, so it's going to be n over 2, but in this case n is going to be not 4, but rather 5. So it's going to be 5 over 2 times the first term plus the last term. So 7 plus 11 is 18, divided by 2 is 9, times 5 is 45, times 6 is 270. 270. So again, just plug in the numbers in, and remember the little trick here. Right, 11 minus 7 is 4, but that means there are actually 5 terms. 5 goes right there. Okay. So, finding the sum of an infinite geometric series, or just geometric series. So, here's the deal. If we are talking about this kind of situation right here, where we have r to a power, if r is bigger than 1, let's say, I don't know, 2, and we raise 2 to the infinity power, right, we're going to obviously get infinity. Even if we raised 1.01 to the infinity power, we would again get infinity. So this whole situation here only works for r's that are smaller than 1. It also works for negative r's, but we'll just keep our discussion for positive r's for the moment. We'll take a look at one, I think, later where we have a negative r. So again, the key thing here is to make sure that r is smaller than 1, because when we raise numbers that are smaller than 1 to an infinite power, well, it's not going to be infinity. So here's our formula. So the sum of all the terms from 0 to infinity of this situation right here, where we have a geometric series, a starting term, and a common ratio to a power, is going to be simply the first term divided by 1 minus the common ratio. Again, a nice simple formula, and yes, I will give you the formulas for your test. All right, so here it is, just applying the formula to this simple problem right here. So we know we're going from 0 to infinity, so we're going to start here at 6. And we're going to do 1 minus 0.2. So 6 over 0.8. So 6 divided by, try to turn on your calculator. 6 divided by 0.8 equals 7.5 again. 7.5. And so I just want to kind of illustrate what's going on right here a little bit. Let's kind of write some of these terms up here. So we know the very first term here is going to be 6, right? Because we put n as 0 right here, so anything to the 0 power is 1. So our first term is 6. And then we're going to add the next term. So 6 times, so the next one is 1, right? So 0.2 to the first power is 0.2. So 6 times 0.2 is 1.2. And then we're going to add on 1.2 times 0.2, which is 0.24. And we're going to keep doing that. And so 6 plus 1.2 is 7.2, 7.44, blah, 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 blah. And so the first 3 terms actually get us fairly close to the actual total sum at the end. So the rest of these terms from here to infinity add up to almost nothing at all. So, which is actually kind of a cool concept. So that's using the formula for an infinite sum for a geometric series. All right, and the last one. Same kind of situation. So we are just going to plug, again, the numbers into the formula. And so we have S of n equals our very first term, which is 2, over 1 minus, so we got negative 2/3 there, so it's going to be negative 2/3 here. So this is going to be 1 plus 2/3, so 1 and 2/3, or 5/3, so 2 over 5/3 equals 6/5. So obviously things are a little bit different when we have a negative, because as we were talking about on this side of the page, where are we down here? So we're going to start with our first term. That'll be a 6, and if it's negative, so negative to an odd power will be minus, and then we'll have a plus, then we'll have a minus, then we'll have a plus, and so on all the way down to infinity. So that's why this sum looks a little different than the other one, because it looks like this would be bigger than 2, just like this one was bigger than 6, right? The starting term is 6, right? The final sum is bigger than 6. When we have a negative, it ends up being smaller than the very first term. So there you go. There's your stuff. I'm going to post this right here as well. So 669, and I'll have a couple of problems from the summation arithmetic sequence, summation notation, and that's it. So that was the final lesson. Stay safe. I'll see you guys on Monday when we do a review session and do our test. And that will be the end, and hopefully, because it's only 3 sections, nobody's got to reassess and everyone will be done. So be safe. See you guys on Monday.